Video, you will learn about how to classify triangles and find the missing angle measure in a triangle. When you classify triangles, you can classify them in two ways. You can classify them by their angle measures and or by their side lengths. When you classify triangles by their angle measures, there are three different classifications that exist. The first one is an acute triangle. An acute triangle must have all three acute angles in order for it to be an acute triangle. An obtuse triangle can only have one obtuse angle. You can see here that's this angle 105, which means the other two angles, 35 and 40, are acute. And finally, a right triangle is going to have one right angle, and the other two angles are again acute, just like the obtuse triangle. When you classify a triangle by its sides, there are also three different classifications. Scalene triangles have no congruent or equal sides. That means all three side lengths are different. Isosceles triangles have two congruent sides. That is noted with these little marks on the side lengths here. These pink lines show that this side is equal to this side. Finally, an equilateral triangle means that all three sides are congruent, and that is shown with the three pink lines on the sides of the triangle. You can also classify them both ways. For example, you can say a triangle is acute and isosceles, or for example, a right and scalene triangle. So when we classify a triangle, we want to pick one word that describes its angles and one word that describes its sides. One other thing we need to make sure we know, and this is because sometimes we are given angle measures in our picture, sometimes we are given marks on the sides in our picture, but what we need to make sure we are aware of is that each side length corresponds to the angle that is opposite of it. Let me show you what I mean. If the sides are the same, then the angles that are opposite of it are equal as well. For example, if a triangle has two equal sides, like this isosceles triangle, it's also going to have two equal angles. And those equal angles are the ones that are opposite of the sides. Here's another example. If we know that AB and AC, those two sides are congruent, you can also conclude that angle B and angle C are congruent because they are corresponding with the side that is opposite or directly across from it. The bigger angle C gets, the longer side AB has to be, because if this angle opens wider, then point A has to be up higher, making that side AB longer. So angle A corresponds with side BC as well as that top angle. Angle B corresponds with this side over here, AC, and finally angle C corresponds with AB. This is important when you're classifying triangles because, as I mentioned, they are not always labeled as sides and angles. Sometimes just the sides are labeled, sometimes just the angles are labeled. Another thing that we need to pay attention to is the interior angles of a triangle. There are three angles inside of a triangle, and they have a sum of 180 degrees. So at all times, the angles inside of a triangle must add up to 180 degrees. This is exactly why when there is an obtuse triangle, there can only be one obtuse angle and the other two have to be acute. If the obtuse angle in a triangle is 100 degrees, for example, in order to make a triangle, we would have to close it across the bottom, forcing these bottom two angles to be acute. Now, they don't have to be equal to each other, They can be, but they can also be different measurements as well. They could both be 40, or this one could be 30, while this one could be 50. As long as it adds up to 180. Let's take a look at some examples. In this first example, the measure of angle K would be found by first adding 135 plus 115, which is 150 degrees. That leaves us with 180 minus 150, which is 30 degrees left for angle K. In this second example, we only have one angle marked, but if you notice, we also have these lines on the sides XZ and XY. If you recall, this side here, XY, corresponds with the angle over here, angle Z. And this side, XZ, corresponds with this angle over here, which is angle Y. If these two sides are equal, then their corresponding angles are also equal. So if angle Y is 58, angle Z is also 58 degrees. So if 58 plus 58 equals 116 degrees, that means whatever is left will be angle X. So 180 minus 116, which is 64 degrees for angle X in the diagram. So angle X equals 64 degrees and angle Z equals 58 degrees. In this example, we need to find the measure of the missing angles. Since we don't know the value of X, we're going to have to write an equation first. What we do know here is that all three angles are different because they all are showing different expressions, but we also know that they have to together add up to 180 degrees. So that will give us our equation of x plus 2x plus x plus 20 equals 180. When we solve this equation, we will find the value of x, which will then allow us to find the measures of angle A, B, and C. So down here, if we add x plus 2x plus x, we get 4x plus 20 equals 180. Subtracting 20 from both sides gives us 4x equals 160, and then dividing 160 by 4 gives us x equals 40. So if x equals 40, then angle A is simply 40 degrees because it is x degrees. If B is 2x and x is 40, angle B is 80 degrees. And lastly, if angle C is x plus 20, and x is 40, 40 plus 20 is 60 degrees, adding up to a total of 180 degrees.